All right, today's lesson is on the unit circle. So, some things before we get into it, because this first will not be the part of the packet that I give you, but an important preamble before we get into the work that's there. A unit circle has a radius of 1 unit. Hence, it's called the unit circle. 1 unit circle. It has a radius of 1 unit. Why is that important that the radius is 1 unit? Well, we're going to find that out soon. Why do we need it? So the unit circle is used to generate trig values quickly without a calculator. So to know the unit circle, first of all, we're going to understand where it comes from. And then when we actually build our unit circle and have an understanding of an expectation to have it memorized, why do we need it? And so if we don't have a calculator, a unit circle is used to generate trig values quickly without a calculator. So what is it? It's a circle that has a radius of 1. Why do we need it? It's used to generate trig values quickly without a calculator. Now, in order for us to understand the unit circle, we need to understand and repeat about 2 special right triangles. So we have 2 special right triangles, and then I'm going to go to the paper that was uploaded. Now, one special right triangle is called 45, 45, 90. And the reason it's special is because you know the angles and the ratio of the sides that go with that triangle. So you know both. Usually you know one or the other, but not both. Here we know both. And so the ratio of the sides is 1, 1, and root 2. Now, if I wanted to know any trig value with 45 degrees in it, I could use this triangle and use Sohcahtoa. That means the definitions of opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Now, when I do that, you could have 1 over root 2 or root 2 over 1 and different things like that. What becomes most helpful, instead of creating a ratio where I have to divide, what would happen if this hypotenuse was not root 2, but was equal to 1? Why would that be an advantage? So first of all, if I want this to be equal to 1, I need to divide it by root 2. Because root 2 divided by root 2 is 1. But if I do that to one side, I have to do it to all the sides because they're in ratio. So I have to divide and divide by that exact same number. Now, I don't like root 2 in the denominator, so I'm going to multiply top and bottom by root 2. So I'm going to get root 2 over 2, and the other side will also be root 2 over 2. But here's the power. If I want to know what the value of sine or cosine is, because the hypotenuse is 1, dividing by 1 does not change the opposite or adjacent side. So instead, if I want to know what the sine of a 45 degrees is, all I need is the opposite side. Because the hypotenuse is 1, when you divide by 1, all you need is the opposite side. So what's the opposite side? Root 2 over 2, and you have your answer. So no longer do I have to divide to get my answer. I can just look at one number only, and there's the answer. Same thing if I had cosine. It's now just the adjacent side. Because the hypotenuse is 1, when you divide by 1, it's just the adjacent side. So the power of having the hypotenuse to be 1 is I no longer have to divide. I just need to know the length of one side, and there's my answer. And we're going to connect this to a unit circle where the radius is 1, like the hypotenuse is 1. All right, let's try this one more time. There's another special right triangle before I shift over. The other special one is called 30, 60, 90. And the ratio of those sides is 1, 2, 3, but this last side is root 3. It's important that when you count, opposite of 30 is 1, the hypotenuse is 2, and the last side is 3, but it's root 3, and that's the one opposite of 60. And again, I want this hypotenuse to be 1, not 2. So I'm going to divide by 2. See, 2 divided by 2, now the hypotenuse is 1. But what I do to one side, I have to do to all the sides. Now the good news here is we don't have a radical in the denominator. It is what it is. But now I have 1/2 and root 3 over 2. And again, the power of that is, if I want to know the cosine of 30, I no longer need adjacent over hypotenuse. Because the hypotenuse is 1, all I need is the adjacent side. So what's the adjacent side to 30? And the answer is root 3 over 2. And all I need to know is that side and get my answer. So I no longer have to divide to get my trig values. So the power of 1, in this case, is dividing by 1 means I only have to care about the numerator, just a side. So I'm not going to go through all the trig values using these special right triangles, but we are going to do it when we look at the unit circle. So we're now going to shift over to the packet I gave you. But I wanted you to understand these basic facts. A unit circle has a radius of 1 unit. The unit circle is used to generate trig values quickly without a calculator. And we get these numbers from special right triangles. And there's 2 of them. And from these 2 triangles, we're changing the hypotenuse to 1. And you're going to see that soon when we do our unit circle. And the reason we want the hypotenuse to be 1 is so our definitions, we don't have to divide. Instead, all I need is the opposite side or the adjacent side. Now notice tangent doesn't involve the hypotenuse, so it's not affected by that. But for sine and cosine, it's easier when the hypotenuse is 1. All right, let's shift over. I'll just go away. So here's this. So a unit circle has a radius of 1. We talked about that. Because the value of r is 1 for each point, x, y, on the circle, the trig functions theta are defined as follows. So I want you to see this right triangle right here as a point on the unit circle. And we know the radius is 1. So what is this side over here, opposite of the angle? That's y. What's this side right beside the angle? That is x. And so first of all, we know that sine very beginning was opposite over hypotenuse. Then in the last lesson, we learned that it's also y divided by r. But now if the radius is 1, this lesson, the sine of the angle is just the y coordinate. Let's go to cosine. So we know cosine is adjacent over hypotenuse. In the last lesson, we learned it was x divided by r. Now, if the radius is 1, cosine is just the x coordinate. Tangent does not change. It's y divided by x like it was before, or the other definition was opposite over adjacent. Both are good. These are just reciprocals. So the reciprocal of y is 1 over y, and of x is 1 over x, and cotangent would be x over y. But today we're focused on here, and the big part of the lesson is cosine goes with the x coordinate, sine goes with the y coordinate, and if you want to know tangent, you got to go y divided by x like we did before. But these first 2 boxes is the big part of the lesson. So the coordinates of P can be written as cosine and sine, because cosine goes with the x value and sine goes with the y value. You can understand the coordinates on a unit circle as cosine and sine instead of x and y. So the unit circle is right here to the right. So we are going to switch over to this sheet and then come back. So here's a unit circle that's partly filled out. Now, in class, we would actually fold a piece of paper, use a protractor, design it from scratch. But here, online, we're going to do what we see right here. So right here, already what's given is I first want you to look at the first quadrant. And notice the 3 angles that we started with, 30, 45, and 60. Now, I'm not going to do this for every point. But if I take 30 degrees and I connect it to that point, and if I make a right triangle, I want you to notice that the radius is 1. And if I go back to this sheet for 30 and 60, right here, We already did the work. Notice what the x-coordinate is and what the y-coordinate is based on that special right triangle. So at 30 degrees, I need you to memorize this, that the x-coordinate is √3/2 and the y-coordinate is 1/2. That comes from special right triangles. Doesn't come from some alien from space. We didn't just pop the numbers out of nowhere. I showed you where those numbers come from. Now we're going to work and remember them. So at 30 degrees, the point on the unit circle is √3/2 and 1/2. At 45 degrees, back to this again. What's the x-coordinate and what's the y-coordinate at that point when the radius is 1? And that's √2/2 and √2/2. Now, I want you to notice this one at 60 degrees connects us to what we did here at 30. And the only difference is between the 30 and the 60, because it uses the same triangle, is that it's the inverse. Because what 60 is opposite of is different than 30 in terms of the inverse of that. So what's the inverse of √3/2 and 1/2? And you have it. Now, if you know the first quadrant, you know the entire unit circle. So 30 is √3/2 and 1/2. 60 is the inverse of that. And 45 is an isosceles. So the x and y are the same number, and it's √2/2. Now, I want you to notice that in this unit circle, we continue to add angles as we go counterclockwise. 30, 45, 60, and then 90. We're going to skip 90 for now. We're going to go to the second quadrant. And we're going to, guess what angles we're going to use? We're going to add 30, we're going to add 45, and we're going to add 60. So again, these angles are 30, 45, and 60, just in quadrant number 2. Now, how does that change things? Well, first of all, I want you to see that if you take the answer from quadrant number 1 and you fold and reflect over, you would get the exact numbers you need in quadrant number 2. So can you fold over the y-axis? Fold over, and you would see the points 1/2 √3/2. You would see, again, if you fold over and reflect, you'd see √2/2 and √2/2. And you would see √3/2 and 1/2. That's if you reflect it over. Now, what's the difference between quadrant 1 and quadrant 2? Well, in quadrant 1, the x and the y are both positive. But in quadrant 2, the x-coordinate is negative and the y-coordinate is positive. So for these that you just wrote down, only the x-coordinates, you're going to put down that they are all negative. Now that you have the top half of the circle outside of 90, you're now going to reflect that whole circle and fold down across the x-axis. So the exact same numbers you just came up with, now we're going to fold down and find the other points. So if I fold this down, this is going to be √3/2 and 1/2, √2/2 and √2/2. And again, I want you to notice the angles. We're adding 30, 45, and 60. So every time we're adding 30, 45, and 60 to get each quadrant. And we're reflecting, folding down to get the points. So once you get the first quadrant, you can just reflect down to get the other ones. So again, you can either reflect over the y or the x to get the points that you need. Now, in the third quadrant, both x and y are both negative. So here, the x and the y both need to be negative. Now we're going to fold over one more time. So what are the points here in the unit circle? So here, we're going to have 1/2 and √3/2, √2/2 and √2/2, and √3/2 and 1/2. Notice the same points repeated. Once I know the first quadrant, I reflect to find the others. Again, in quadrant 4, x is positive and the y-coordinate is negative. So here, just the y-coordinate will be negative. So just by understanding the first quadrant and special right triangles, we can reflect and know the quadrant signs, positive or negative, and fill in almost every point on the unit circle. Now I said we get back to 90 degrees and 0 and so on. So if this has a radius of 1 and this unit circle is at the origin, that means this point is 1 and 0 right on the axes. So we're just going to put in 1, 0. 1 to the right, 0 up or down. Look here at 90 degrees. Where is that? If this is on the axes, this is the origin. What point is that? It's just going straight up, and the radius is 1. So it's 0 and 1. If I look at the left of the unit circle, notice we're just going straight left, so it's -1 and 0. And then the last point, we're going straight down, so it's 0 and -1. And you have just completed the entire unit circle. And then the question, of course, is how do we use it, when do we use it, and so on. We're going to get to it when we do our work. But I just want to be able to expand here so you can see the whole unit circle and that you're comfortable with that. There it is. So you can press pause if you need to. But what did we do again? What did we have to memorize? At 30, root 3 over 2 and 1/2. At 45, root 2 over 2 and root 2 over 2. And at 60, 1/2 and root 3 over 2. And these get memorized by practicing. They come from special right triangles and changing the hypotenuse to 1. But you're going to remember this as you practice the questions that we're doing. Once I know the first quadrant, I reflect, I reflect, I reflect, and then I understand the signs of x and y in which quadrant I'm in. If a point is on an axis, and this is the y-axis, and this is the x-axis, then all you use is 0 and 1. So it's straight right would be 1, 0, straight up is 0, 1, straight left is -1, 0, and straight down is 0, -1. So there is the unit circle. Make sure as you practice the questions that you can use the unit circle, and then try practicing without it to see if you have it memorized. All right. Positive trig values. In quadrant 1, all trig values are positive. In quadrant number 2, sine is positive. And I want you to remember the signs here. This is going to help you remember it. So positive, positive, negative, positive, negative, negative, and which one did I do? Positive, negative. Okay. Let me zoom in here. So everything is positive in quadrant number 1. But in quadrant number 2, and maybe it's also helpful to understand here on the right, again, sine goes with the y coordinate and cosine goes with the x. So both x and y are positive. That makes everything positive. Tangent is y divided by x. So a positive divided by a positive, everything's positive. Only the y coordinate is positive. So which one goes with the y coordinate? Sine. These would almost be negative answers. The only thing else that would have a positive answer is the reciprocal of y, which is cosecant. How about quadrant number 3? Negative, negative. So in this case, sine is negative, cosine is negative, because both the x and y are both negative. So which one would be positive then? Well, tangent's done by going y divided by x. So when you go a negative divided by negative, it gives you a positive answer. So what is positive in quadrant number 3? Tangent. Now, the reciprocal of tangent would also be positive. So also would be positive there is cotangent. The last quadrant. This is where the x-coordinate is positive. So where is the x-coordinate being positive? That's cosine. And then its reciprocal, which is secant. So sometimes it's challenging to understand whether the answer is positive or negative. So this is one way to understand whether the answer is positive or negative, knowing what quadrant the angle's in. I want to notice another acronym. Remember Sohcahtoa? So here's one right here to remember it. ASTC, which is all students take calculus, as a way to remember this. ASTC. So when you're wanting to understand what quadrant it is, draw a set of axes and write down all students take calculus. And then you have an understanding and an organization to know whether the answer is positive or negative. So everything is positive. Sine is positive, and it's reciprocal. Tangent is positive, and it's reciprocal. And cosine is positive, and it's reciprocal. So this can help organize to understand what quadrant we're in, to know if the answer is positive or negative. All right, this is a big time important sheet for you to do. All right, so make sure you have it with you and you did a good job. Press pause, make sure you didn't go too fast. We're going to come back to this. Now, before I leave this, I want you to understand that the angles here, we added 30, 45, and 60. And then we have 90, 180, 270, and 360. And then from the quadrants, we just keep adding 30, 45, 60. Again, from the axes, 30, 45, 60. From the axes, 30, 45, 60. That's where the angles come from. And then one full rotation brings us right back, which is 360. Which was given for you are the radians that also go with it. Now, I want you to recognize this, that to change this to radians, we know it's pi over 180 and then reduce it down. So pi over 6, pi over 4, pi over 3 are just converted degrees. But I want you to notice that when you do a reflection in terms of the point, what do you notice about the denominator? So at 30 and at 150, and again, if you reflect again down, at 210 and at 330, they all have a denominator of 6. Now we learned that this angle made with the axes is called the reference angle. So if a reference angle is 30, that's that angle from the horizontal, then what's in the denominator? 6. If the reference angle is 45, what's in the denominator? Every time. Look at each quadrant in the denominator as a way to remember the radians. And then the last one, how about 60? If the reference angle is 60, that's the angle made with the horizontal. What's in the denominator? And for each one you can see, for that one, the denominator is 3. And if it's on an axis, on the x-axis is 0, pi, 2 pi, and we're just counting up by pi. And on the other axes, the denominator is 2, pi over 2, 3 pi over 2, and so on. One way to remember the radians is to start with pi over 6 and then start counting over 6 as you fill in. So this is what I mean. And we're going to be skipping the 45 degrees when we count, because that's a separate count to remember. So here we go. 1 over 6, skip 45. 2 over 6, that's 1/3. 3 over 6, that's 1/2. 4 over 6, 2/3, skip it. 5 over 6, I can't reduce it down. Next, 6 over 6, which is pi, 1. 7 over 6, skip the 45. 8 over 6, reduce it down. 9 over 6, reduce it down. 10 over 6, reduce it down. Skip. 11 over 6, 12 over 6. And just by remembering 1 over 6 at the beginning and counting 2 over 6, 3 over 6, and so on, you can remember the radians around the whole circle. Now, how do I remember the 45s? Well, they're always over 4. So 1 over 4 is there at 45. Now 2 over 4 is already there at 1/2. So the next one would be 3. So the pattern for 45s are odd numbers. So 1 over 4, 3 over 4, 5 over 4, and 7 over 4. Now this is a unit circle only to 360. Angles go on to infinity. So we can continue to use this and keep counting if we know the reference angle and what quadrant it's in. So you could find values beyond 360 and negative angles as well. All right, so that's the unit circle. Now we're ready to come back and answer some of these questions. So the unit circle is used to map 30, 45, and 60 and their multiples, as well as the multiples of 90, which are the quadrant angles. So what we're going to do here is we're going to answer this right here. So to understand how to use the unit circle, we need to know that the x-coordinate is cosine, that the y-coordinate is sine, that when I go y over x, it's tangent. That's like the foundation I need to understand. So let me guide you through it. So first, what's the value of sine at 135? So because you don't have it memorized yet, the first thing I would say is if you looked off the unit circle, could you find 135 and tell me the point that goes with 135? So the point that goes with 135 is negative root 2 over 2 and positive root 2 over 2. Next, sine goes with the y value. What is the y value here? And the y value is positive root 2 over 2, and you have your answer. So it starts with knowing the point on the circle, and then the definition, and then you have your answer. 180. Can you find that on your unit circle where 180 is? Tell me the point at 180. So when you look off the unit circle, the point at 180 is negative 1 and 0. Next, tell me the definition for secant. Well, it's the reciprocal of cosine. We just said cosine's x. So I'm looking for the x coordinate, but I'm doing the reciprocal of that. Now, in this case, I have negative 1. How do I flip negative 1? Well, negative 1 means negative 1 over 1. And when you do the reciprocal, you get positive 1 over negative 1. In other words, you get the exact same answer. So the reciprocal of negative 1 is negative 1. Just like the reciprocal of positive 1 is positive 1. All right, number 13. Negative 300. Oh boy, what am I going to do now? There's no negative angle. So I need to be able to measure and find the reference angle that's equivalent to negative 300. So what might be positive here is to add 360 to find a coterminal angle. So I'm going to add 360 and find a coterminal angle, which is at 60. That's going to give me the same answer as negative 300. Then what's the point on the unit circle at 60? So look off the circle if you need to, but it's positive 1/2 and positive root 3 over 2. What's the definition of cotangent? Well, it's the reciprocal of tangent. So the reciprocal would be x divided by y. Then when I look at this point, tell me the x value and tell me the y value. So it's 1/2 divided by root 3 over 2. Now, the good news here is that the denominators are the same. So if I multiply by 2 top and bottom, they actually divide out. That leaves me with 1 over root 3. And then if I write that correctly, by multiplying top and bottom by root 3, I get root 3 over 3. All right, number 14. What's the value of cosecant at 120? I first need to know the point on the unit circle that goes with it. So for 120, you can look up your circle. What's the point at 120? And it's negative 1/2 and root 3 over 2. What's the definition of cosecant? It's the reciprocal of sine. So it's the reciprocal of the y-coordinate. So can you find the y-coordinate, do the reciprocal, and then multiply by root 3 top and bottom to get your answer. Number 15, 270. Find that on your unit circle. Well, that's 0 and negative 1. What's the definition? It's y divided by x. Now, when I see this, y divided by x, I get negative 1 over 0. And y over x, negative 1 divided by 0, means the answer is undefined. Because when you divide by 0, or have a 0 in the denominator, there is no answer for that. So when there's no answer for that, it is undefined. Number 16, cosine negative 150. So again, I'm going to add 360 to find a coterminal angle to make it easier. So negative 150 plus 360, if I put that together, that's 210. Then, when I look off my unit circle, what's the point at 210? So it's negative root 3 over 2 and negative 1/2. What's the definition for cosine? That's the x-coordinate only. So only the x-coordinate, negative root 3 over 2, and you have your answer. 17, 3 pi over 4. So now we're in radians. So can you find 3 pi over 4 radians? What point goes with it? That's negative root 2 over 2 and positive root 2 over 2. What's the definition for cosine? It's the x-coordinate. What's the x-coordinate? Negative root 2 over 2. Done. And you have your answer. Tangent at 2 pi over 3. So find 2 pi over 3. What's the point on the unit circle? Negative 1/2 and root 3 over 2. Then, what's the definition for tangent? Y over x. So then when I look at the y and I look at the x and I divide these, I want you to notice they both have a 2 in the denominator. When you multiply top and bottom by 2, they divide out. And what you're left with is root 3 over negative 1 or negative root 3. So I don't need to rationalize anything there because there's no square root in the denominator. So it simplifies to negative root 3. 19, pi over 2. Find the point on the unit circle. That's at 0, 1. What's the definition of cotangent? Well, cotangent's the reciprocal of tangent, so it's x divided by y. So in this case, x is 0 and y is 1. Notice that 0 divided by 1, that answer is not undefined. 0 on top, good. 0 on the bottom, bad. 20, secant negative pi over 4. So again, when you have a negative angle, we can either use the unit circle and go clockwise 45 degrees, or we can find a coterminal angle. So if I add 2 pi to find a coterminal angle, I'll get common denominators. And what I get is 8 take away 1. That is 7 pi over 4. So can you find 7 pi over 4? What's the point on the unit circle? That's root 2 over 2 and negative root 2 over 2. What's the definition of secant? That's the reciprocal of cosine, so it's the reciprocal of x. So if I take the x coordinate and do the reciprocal, I get 2 over root 2. Now if I multiply by root 2, top and bottom, I get 2 root 2 over 2, and then the 2's divide out. So really the answer is just root 2 when you write it properly. 2 more, and then the lesson's over. 5 pi over 4, can you find that on your unit circle? What's the point? Negative root 2 over 2, negative root 2 over 2. What's the definition for tangent using a point on a unit circle? And it's just y divided by x. So if I look at these numbers and just go y divided by x, notice that you have negative root 2 over 2 divided by negative root 2 over 2. Whenever you have a number divided by itself, the answer is just 1, no matter how complicated the number looks. So negative root 2 over 2 divided by negative root 2 over 2, a negative divided by negative, the answer is positive 1. All right, last question, number 22. Cosecant negative 5 pi over 6. So again, it might be helpful to get a coterminal angle. So I'm going to add 2 pi because it's in radians instead of adding 360. And I'm going to get common denominators. So I'm going to multiply by 6. And then I'm going to simplify it. So 2 times 6, that's 12 take away 5. That's positive 7 pi over 6. Look on your unit circle. That is negative root 3 over 2 and negative 1/2. Now, what is the definition for cosecant? It's the reciprocal of sine. So sine's the y-coordinates. The reciprocal is 1 over y. So take the y-coordinate only and do the reciprocal. So what's the reciprocal of negative 1/2? And the answer is negative 2. So the sign stays the same when you do the reciprocal. All right, I know that I can tell you that's a big, big lesson that we just did. And it's not just going to be learned just by doing it for, 30 minutes. It's something we're going to practice and something that you're going to see in calculus and in other college level mathematics. And I know it's an introduction for you, and I know it's not perfect when it's just done online. But thank you for doing the work with me. Mr. G Math over and out, and the next one will be a homework video on this. So again, we're going to practice, and all you can do is your best. I promise you, it will be good enough. Mr. G Math, over and out.